I'm going to say it again. So pretend we did not hear it all. All right. So again, the midpoint is x2 plus x1. That order doesn't matter. You can do x1, x2. You're just adding the x's divided by 2. Y2 plus y1, or y1 plus y2, same concept. So then this is your x1, this is your y1, this is your x2, this is your y2. All right, we're back to where we are. All right, so therefore, if I wanted to know the midpoint of x, I'm just going to do 1. This is going to be 1 plus -5 divided by 2. And then this is going to be 8 plus 3 divided by 2. So now we're just going to do the work. What's 1 plus -5? -4. So I get -4 divided by 2. And then what's 8 plus 3? So then I get 11/2. Simplify if you can. -4 divided by 2 is -2. Can I simplify 11/2? Let's keep it as a improper fraction. So we're going to keep it as 11/2. I would not count off if you did turn it into a decimal as long as it's an exact decimal, but fractions just look so much better. Like you would technically turn it into a decimal so you can see that it's 5.5. Yeah. I'm good either way. So like if you wrote this as the answer, I wouldn't count this off. There's a thing between mathematicians and engineers. Mathematicians like fractions because they're the exact answer. Engineers like decimals because they're just rounding it anyways. That's why all of our buildings are a little off. Just kidding. This is just a thing between mathematicians and engineers. All right. Any questions back in geometry? So that's 5.5, not 55. I'll make that point a little bit. Yeah, on your Apex for most of us. Or no, did y'all use Apex? Yeah. Yeah. So this is supposed to be what you learned in geometry. Find the midpoint of 2 points on a line segment. All right. This is geometry. We're going to bring that into our complex. Any questions on how to calculate this? Pretty straightforward. Add your x's, divide by 2. Add your y's, divide by 2. Simplify if you can. All right. So let's put this in complex terms now. And it doesn't really get any harder. So now notice that these are pretty much almost the exact same situation. You have a complex number of 1 plus 8i, and you have a complex number of -5 plus 3i. The only first step you're going to do differently is write those as coordinates. What is 1 plus 8i? 1, 8. And then what's this as a coordinate? -5, 3. And then you're going to do the same work. On a textbook, it's going to be slightly different. It's going to look like this for the midpoint. Math doesn't change, so don't get too worried. It's still going to be your, how they break it up. Yeah, they still do x1 plus x2 divided by 2, and they still do y1 plus y2 divided by 2, but the only difference is they're going to bring an I right there to represent the imaginary part, right? So therefore, our endpoints after doing this work would be -2, 11/2 I, right? Well, I say that. It's 11/2. And then when we write this out, it ends up being -2 plus 11/2 I. Hey, comment. There you go. So instead of it being back to a coordinate, we can make it back to a complex number. So this complex number will be the midpoint of these two complex numbers. Questions? If we were to graph this, you can actually see it as well. So let me try to do my best drawing. So if I graphed 1, 8, that's 1, 1, 2, 3, 4, 5, 6, 7, 8. Here's my first point. 1, 2, 3, 4, 5. 1, 2. Here's my second point. So if I wanted to graph this, this would be 2 over and then 1, 2, 3, 4, 5.5, which is roughly right there. Would you argue that that point in the middle is about the midway point of those 2 points?
Yes.
So we know we've done our math correctly. If this point is somewhere not even in the same line as those 2 points, might want to check your work. It's usually going to be a sign situation, not usually a math situation, but you'll not carry over a negative correctly. Confusion at all. All righty, let's move on. All right, so that's that. Exercise 2. Okay, this part here is basically what they're explaining. Don't need it. Y'all don't do well with proofs. So we're not going to prove it. Just take my word that this is your formula. All right. Unless y'all don't believe me, I will show you the proof. Yeah, I need to see the proof. Okay, good. Don't have trust issues in this class. So in exercise 3, it says the endpoints are this and this. What is the length? All right, so now this is something a little bit new. Length to us tells us what? What are we looking for? The distance, the modulus, the vector distance, or whatever in that case. That's exactly what you're gonna do. And beforehand, this was what? But that was because our vector started where? At the origin. What's the coordinate for the origin? 0, 0. So adding or subtracting a 0 to a point, will it affect that point? Not adding or subtracting a 0, no. So we just kind of just got rid of it. Let me show you this right. Oh man, I should have kept it. I'll just draw it again. So this would be, again, here it is right here. I feel like this one's going to be worse. So what we're trying to do is we're trying to figure out what this distance right here is. Right? And beforehand, when we showed us how to do distance, what did we form? A triangle, right? So we would have to go ish, something like that. And then how would I figure out how I would go from here to here? Okay, so I'd go 1, 2, 3, 4, 5, 6. So I went 6 over, right? And then over here, how much did I go up? 5. That's 5, or should be 5, right? And then that's what you can do graphically, right? But what we're doing algebraically is you're really just subtracting these two guys to figure out their distance. So what is, if I was to work this out, what was the first point? 1 minus -5, right? If we subtract those two, what's 2 negatives going to make? The x values. So I was, well, actually, I guess I should have started here. It doesn't matter. So if I go from this graph here, that was actually -5 minus 1, same process. But what would I get? -6. -6 and 6 are going to be the same distance. You'll see that here in a second. And then how would I determine this one algebraically? It's subtraction. So the formula here would just be like x1 minus x2. If I want, yeah, I just subtracted the two formulas. We'll get to the formula all together here in a second. But then how would I calculate that 5 there? What would I do? How did I calculate this 5? Without counting algebraically, what could I have done? Just do 8 minus 3, right? What's 8 minus 3? 5, right? This is just the difference of your y2 and your y1. The order doesn't matter when you're subtracting, right? Now, I finally calculate this, but how would I get this equation here? I would have to do something before I just added them. Pythagorean theorem tells me to do what? A squared plus b squared. So I now have to do this -6 squared and this 5 squared. So this becomes a plus. So notice what happens if I square a positive or a negative? What's going to happen? It's always going to be positive. That's why this order doesn't matter. Just find the difference of the two numbers. And when you square it, the result's always going to be positive. So what's -6 squared? 36. What's 6 squared? 36, but I got you. You're getting ahead. But it would be 36 regardless on either end. But 5 squared is 25, right? Now this would be what C squared equals. So what's 36 plus 25? 61, right? Is it 61, guys? I got a second on that? Yes. All right, cool. And then that's what C squared equals. So then what would be the last step to find this hypotenuse? Square root. There's your answer. So to put this in a formulas aspect, this will be the square root of the difference of your x's squared plus the difference of your y's squared. Right. Technically, this is the exact formula we use when calculating the distance that we had earlier, but when we're taking the difference of 0, it doesn't change. It ends up just being the a and the b. All right. Questions. So again, this is also something you did in geometry as well. Go ahead. Oh, maybe because my drawing's not very good, but I'll do it. So if I'm going from -5 to 1, that's 1, 2, 3, 4, 5, 6 right there. And if I count the lines, I'm going 1, 2, 3, 4, 5. Why did I skip what? The line that it's on? You don't ever start with the line you're on. Yeah. Then you take a step. Now you're yeah. So like on football, if you're on the 10-yard line, I then went to 11. That'd be the difference. So I went 1 up. I didn't count 10 and then the 11-yard line. That's not 2 yards. So yeah, when counting, you never count what you're on. Okay. Any other questions like that? All right. But if the graphing part is getting you, just subtract the 2. You're just finding the distance of each x and y value. All right. Yes. To find midpoint. So 2 different formulas. Midpoint, I'm just trying to find the average point in the middle. Distance, I'm trying to calculate the entire length. That's why we subtract it. Yes, ma'am. Go ahead. Yes, sir. Any other good questions like that? So there's 2 formulas we've gone over. Midpoint is the average complex number between 2 complex numbers. The distance formula here is to calculate the entire modulus of that line segment there. All right. Which is, again, what you're technically doing in your physics class for anyone that's taking physics. He's just put an application to it. All right, so what I want you to do real quick. What is that? Oh, okay. Well, if you look at this, everyone got this? Example 4, exercise 4 here is kind of redundant. But notice, instead of just coordinates, what's the extra step I'm going to have to do the work? I'm just going to have to make these a coordinate. So 1, 8, and then -5, 3. And then I'm right back to the exact same problem I got. So I get the square root, and we'll put this all together so you can see it. But I'm just going to do 1 minus -5 squared plus 8 minus 3 squared. 2 negatives make a what? Positive. 1 plus 5? 6. So this becomes 6 squared. 8 minus 3? 5, good. 6 squared? 36. 5 squared? 36 plus 25. So we get to the same conclusion. So I first, y'all can't keep y'all's hands off each other. I ask y'all to move, right? Try to take your personal time outside of the class, your affection for each other. All right. So there you go. So again, when it comes to complex, you're just doing that one thing of changing it to a coordinate, but then the math doesn't change versus what you saw in geometry class. And then this is where the formula is used as applied rather than having to go around using the rise over run concept of Pythagorean theorem. Any questions on that? Again, I'm not going to prove it to you. If you want to proof, we can definitely do it. There are tutorials. I love doing proofs, but I'm not going to make y'all lost again. Let's go ahead then and move into exercise 7. Is there a hand? Okay. I say 7, 5. I can't count. All right, so this one says, suppose Z equals that, W equals that. I want y'all to find the mid. Okay, I want you to find the midpoint where they're going to call it M. So that's just the name of it, but you're finding the midpoint of Z and W. So go ahead and try that real quick. And we'll work B out together. We have the answer. I still see pencils moving. I'll give you a little more time. Are we ready? So again, to find this midpoint, I'm just going to add up my real terms. So that's going to be 2 plus -3 divided by 2. And then I'm going to add up my imaginary terms, which is just going to be 7 plus 1 divided by 2. Before I go any further, did we at least get the correct setup? So midpoint we add, distance we subtract. Right? 2 plus -3 is, so this becomes -1 divided by 2. 7 plus 1, so this becomes 8 divided by 2. I do ask that you simplify if you can. Can't really do anything with that fraction there, so that's -1/2. And then what's 8 over 2? 4. So the only difference when we're looking for the midpoint of a complex number is we're just going to then rewrite this as a complex number. How would you rewrite this as a complex number? Very good. Yeah, so beforehand, we were looking at just coordinates, so that would be it. But since we're looking at complex numbers, we're going to finish our answer as a complex number. So the midpoint of that guy is that guy. And they just gave it a name M. So this can kind of get confusing because you might be like, what is M? Well, you're calculating M. So now this is what M would be. So we're good there? All right, so let's do B, which it wants us to verify that the distance from Z to M is the same distance as M to Z. All right, so what we're first going to do is subtract the 2. Why would we do that? Yeah. Yeah, we're not going to do that. I don't know. We're going to find the distance of Z to the midpoint and the midpoint to W. So what we're going to do here on the left side, I know I'm really digging this green. I'm going to keep it here. So let's do this left side first. All right, so we're going to find the distance, which now we know our formula. No, that's just me not connecting my lines. So this right here would just be the distance formula. So I'll write it down again for you. Okay. So we're just going to use this. So we're going to find the distance of this first side. And my Z would be 2 minus -3. Bless you. Again, if you went -3 minus 2, you're not incorrect. We're both going to get to the same conclusion. Then I'm going to find the distance of my imaginary. Oh, my bad. Not 2 minus 3 because we're looking at M. It'd be 2 minus our -1/2 here. Good thing we don't use pen, right? That would have been a close one. Right? So Z minus M, 2 minus what I got for the M over there, plus 7 minus the imaginary part of my M, which in this case is 4 squared. And now let's work it out. 2 negatives make it. You say you're confused? What did I lose yet? All right, so the ZM is the distance I'm looking for. And then M is what we calculated over here. So I messed up at first and I was looking at W. So I'm going to do my real part. So I'm going to take my 2 minus the real part of -1/2 plus 7 minus the Y value or the imaginary part, which is -4. Any other good questions like that? All right, 2 negatives make a positive. What is 2 plus 1/2? 2.5. All right, we'll keep it a decimal. I would have also accepted 5/2. And that's going to be squared. 7 minus 4, 3. 2.5 squared. Anyone can do it without a calculator? Very good, very good. 2.5 squared, FYI, is just 25 squared, which is 625. But then when you have two decimals, just move the decimal over. Quick math, it's okay. 6.25 plus what's 3 squared? 9. And I'm running out of room here. What is 6.25 plus 9? I'm just going to leave it at this point. If you went ahead and put that in the calculator to calculate a new decimal, that is fine. But that is the square root of 15.25. And just verify that they are the same. All right. So then I'm going to do it again. But this time doing W minus M. So that means I'm going to start off at -3 as my x1 minus the -1/2 squared plus now do the difference of your imaginary part. So that's an imaginary 1 there minus the imaginary 4 squared. Again, 2 negatives make a positive. What's -3 plus 1/2? Not quite. Huh? 3. It'd be -2.5 or -5/2. Because technically that would be the same thing as -6/2. And then when we add the 1 to it, it becomes a -5/2. But I'm good either way. I'm going to write -2.5 squared. And then what's 1 minus 4? -3. And then we do it again. What is -2.5 squared? 6.25, because we know anything that's negative is just going to give me a positive number. And what's -3 squared? +9. It's always going to be a positive when you square it. And then 6.25 plus 9 gives me, again, if you wrote it further out, you would see then that you would get a different answer, but it would still be the same. So square root of 15.25, square root of 15.25, you have just verified. Okay. Questions? All right, you do have problem sets, problem 1 and 2, but you can scratch out F through I on problem 2. So F through I on problem set 2, you can scratch out. The rest of them is just practice of finding midpoint and distance. You can work in groups, work in partners. This assignment will officially be due Tuesday of next week.